In this video, I want to use the triangle proportionality theorem and the triangle angle bisector theorem to solve some problems with triangle proportionality and proportional segments. So let's get into it. Here I have two triangles. Now remember, the triangle proportionality, we have kind of a new way and an old way. The triangle proportionality theorem states that this side length right here, let me get my brush out. Excellent. This right here and this right here is proportional to this right here and this right here. That's the triangle proportionality theorem, and that's so powerful for us. So, since this is 14 and this is x, I'm going to call this little piece, and we're going to do, this is going to happen a lot in these problems. I'm going to call this little piece right here 14 minus x, right? You could call it y, but I know that whatever this is, it has to add, if I add this and x, it has to equal 14. So that's 14 minus x. So then I know that 14 minus x over x is equal to 6 over 10. Okay, 6 over 10, that actually simplifies to 3 over 5. And now I can solve. 3x is equal to 5 times 14 is 70 minus 5x. So then we get 8, add 5x to both sides. 8x equals 70, so then x equals 35 over 4, right? 70 over 8 is 35 over 4. So that's x. Which is a weird number, but that's okay. Especially with proportions, sometimes we're going to get weird numbers. Okay, now I have to be careful because 9 over y, I'm comparing this small triangle right here to this big triangle right here. So I can't set that proportion equal to 6 over 10. But I could set it equal to 6 over this whole side, which is 16. So 6 over 16 is equal to 9 over y. Now, can I reduce this? Yeah. 3 over 8 equals 9 over y. And again, like I've talked about in previous videos, what could I multiply this top and this bottom by to get, or this top by to get 9? If I multiply the top by 3 and the bottom by 3, I get 9 over 24 equals 9 over y. Well, y must be 24. I'd just rather do that than cross multiply if I can help it. So x is 35 over 4 and y is 24. Not too shabby. Okay, let's look at number 2. So that was the triangle proportionality theorem. Now let's look at the triangle angle bisector theorem. The triangle angle bisector theorem states a few things. I know that 6 over y is equal to 9 over x, right? These kind of same sides. Or I could say 6 over 9 is equal to y over x. Right? Kind of these the same as well. And always check your cross product. 6 times x, y times 9. 6 times x, y times 9. We're good to go. Okay, so those are two equations. And I have two equations, two variables here, so I could solve, but the only reason I have two equations is because they're the same equation. Duh. Okay. So what I'm left with is this, and then another equation I could make. Well, right here, I know that this is 10, so x plus y equals 10. There's a variety of ways you could go about this. I personally don't mind doing some multiplying out these denominators to get a simplified equation. So that would be 6x equals 9y. If I don't know. Whatever you want to do, right? Maybe you solve for x. And we get x equals 3 halves y, right? 9 over 6, it simplifies to 3 over 2. And then I can substitute x plus 3, oops, I don't want to do that. I'm substituting for x, so it's 3 halves y plus y equals 10. 3 halves plus y, well, this is 2 halves, right? So that's 5 halves, y equals 10. Multiply by 2, divide by 5. We get y equals, I know I'm running out of room, y equals 10 times 2 is 20, divided by 5 is 4. So if y is 4, x is 6, because x plus y is 10. Okay. So, I mean, really, as long as you can get these two equations right here, oops, as long as you can get these two equations right here, how you solve it is not super important, right? It's just a system of equations. Okay. Let's look here. I have 11. Oh, that's very kind of this problem to give me right off the bat that I know that this is 5. Could it be that easy? 5 over 6 equals x over 10? I guess it is. So 6x equals 50, or x equals 50 over 6, which is 25 over 3. So x is 25 divided by 3. Again, don't be afraid of fractions. They're just numbers. So that was quick. That was nice. And we didn't have to do anything tricky there. Okay, last one. The perimeter is 26. Okay, this is going to be a little bit tricky. So the perimeter is 26. That means 6 plus 8 plus x plus whatever this is equals 26. So what is this entire side length? Right, what is this big side length? Well, 6 plus 8 is 14. So 14 plus that side length is 26. That means this side length is 12. Right? 26 minus 6 is 6, minus 8 is 12, okay? So then this length right here, just like I did above, is 12 minus x, because this plus x is 12. So then now I've got something I can work with, right? And whatever you like, right? We can do 6 over 12 minus x equals 8 over x, or you could say 6 over 8 equals 6 over 8 equals 12 minus x over x. Whatever floats your boat. This second option is kind of nice because it simplifies, right, to 3 over 4. So I get 3x equals 48 minus 4x. Add 4x to both sides. I'm going to go down here. 7x equals 48. That's not quite 7, even though it's close when we divide by 7. X is just that fraction, 48 over 7. And that's okay. Like I said, sometimes you're going to get fractions. They're just numbers. So there's some examples of how to use not only the triangle proportionality theorem, but the triangle angle bisector theorem. And I hope that clears things up for you.